Hey, this is welcome back. It's been a couple days actually. I was so busy trying to figure out what to do, what you guys were going to do for the next 4 weeks. Anyway, I'm ready though, ready to make the rest of the videos. I'll just make one every day is what I'm thinking, and then I'll be posting it, and then you can do the work. If any of you are listening to this and you're not in my class, I'll figure out how to put in the info where the practice questions are in case you want to practice and learn the material. So let's get started. Okay, so this is video number 4 actually on section 9.1. This is 9.1 from our Big Ideas book, but if you're not doing Big Ideas, you still have to learn the material for Geometry and Algebra 2 anyway. It just would have a different section number. So 9.2 I'm calling the second day. This is usually what I teach on the second day. But this is actually the 4th video. The 5th video, I believe. Yeah, this is the 5th video. So this is the 5th video. I might be able to do the 5th and the 6th video. I was thinking there was, yeah, I think I'm going to do all of these in one video. So it's really the 5th video, and there's no 6th video. So anyway. So let's see. Just a quick review of what you did before. Make sure you do the practice questions for videos 1 through 4 before you start doing the video or listening to video 5. Particularly for video 5, you're going to need to have watched video 1 and taken notes on that and practiced it if possible. And then also video 2. So video 3 and 4 are not helpful for video 5. So make sure you've watched video 1 and video 2. Okay, the actual topic, well, I probably should put the name first. So let me put the name before I put review. So the real name of this topic is going to be simplifying cube roots, fourth roots. So nth roots just mean if you wanted anything higher. Simplifying them and rationalizing denominators with roots higher than 2. Now you'll hear me using these words that are all really the same. So I sometimes call them square roots. I also call radicals. Okay, so roots and radicals are kind of the same thing. You'll hear me say square root, cube root. You'll hear me call it a radical. It's really the same thing. Roots and radicals are the same thing. Okay, so let's try one. Okay, well, let's talk about the review. So let me just give you a quick review, okay? Just to get your mind back in it. Okay, so if you had the square root of 72, that means there's nothing in the corner, but really it's a 2. Okay, so the 2 is not there, but it really is there. Not there, is there. And that's because it's a square root. Okay, so I'm going to leave it in because it'll help us with the cube root. So this is because we call these square roots. We don't want to write the 2 in the corner every single time because we do with square roots more than anything else. Okay, so this is a square root. Okay, so what a square root is when we're simplifying it is the way I was showing you as we were making a tree. So there's other ways to do it, but the tree method is most helpful, in my opinion, if you're not a math teacher. Because if you're a math teacher, you really know all the perfect squares. So you'll see something like the square root of 147, and a math teacher would say, oh yeah, that's 49 times 3. But a student probably doesn't know that's 49 times 3. You know, we teach it over and over and over every year. So from a student's perspective, I like the tree method better than the perfect square root method. Okay, so I don't teach that way with the cube roots either. When you look at the textbook is using kind of the math teacher way, where they just magically know what cube roots and square roots and multiplications are. But I think that's a little more difficult when you're a student. So I'm going to show you the way that works the best if you don't have a calculator. And you never know when that's going to be the case. The SAT has a non-calculator section. It also has a calculator section. AP, for AP Calculus, has a calculator section, has a non-calculator section. If you're in college, maybe yes, maybe no, depends on the professor. Okay, so I'm not going to show you that way. Okay, so I'm going to show you this way. So basically what you do is you make your tree. Now, these things I have at the bottom, because it's a square root, so I'm going to highlight that part. So since it's a square root, it means I'm looking for pairs. Okay, so the way I call it is I say pairs escape. Okay, so if you remember from first semester, what I called it is I said they escape jail. Okay, so this is square root jail. So square root jail, you need yourself and a twin to escape. So the 3 has a twin. So the 3 and the 3, they escape from jail. And the 3 comes out of the radical. So if you kind of think of this being a big radical right here, the 2 3s means that you escape from jail. Okay, so when you escape, team 3 escapes. Now, do I have another team? Now, because of the 2 in the corner, the yellow 2, you have to be looking for a group of 2. It also escapes, and you put that number out here as well. Okay, so that's a 2. So I have a 2 and a 3 out there, and you multiply things that come out. So that would be 6 square root of 2. Technically, you still have the 2 in the corner, but usually people leave it off. You just want to make sure there's no other number that looks like it's in the corner if it wasn't a 2. Okay, so that's square roots. Now, what's new, so let's put new. New, we did it first semester, but you haven't seen it in a while, is what if it's a cube root? Okay, so what if it's a cube root? So a cube root, you make the tree in exactly the same way. So I would make the tree. I'm going to make 5 things because we already made the tree in the last one. Okay, so you have a tree, but this time in the corner, so I'll highlight it in blue. It's called the index. So the 3 in the corner means that you're looking for groups of 3 instead of groups of 2. So you have to be a triplet to escape. It's like a more secure jail. Okay, it's a more secure jail. So the 3s, I only have a pair. So twins are not enough to get out of the higher security prison of the cube root. Okay, so I need 3 of them. So I do have 3 2s. They don't have to all be in a row, but in this case, they happen to be in a row. So I'm going to escape the cube root jail. So I don't usually write the jail on top here, but that might be helpful. Actually, it's something helpful for something we're learning later today. So maybe I'll kind of draw it on top of the thing. I might do it that way next year because that's kind of cool. Anyway, so what escapes? So the 2 escapes and the 3s get stuck inside. So the 2 is there. It's still cube root jail. So you want to make sure that looks like it's in the corner. And then there's 2 things left. So you re-multiply things that are left. And then this would be the answer. Now, if you typed it into a calculator, if you figured out how, 6 square root 2 and 2 cube root 9 would be different. And the reason they're different is because one says I need 3 of them to make 27. And this one is saying I only need 2 numbers to multiply to be, not 27, 72. And 2 numbers to multiply to be 72. Okay, so we had done that before, so let's just practice a couple more of those. And I want to throw one in with a letter, which we did not do first semester. So let's see. Okay, so this one is, so we'll call this example 1 over here. I'm going to call the new one example number 1. Okay, so example number 1, and let's see example number 2. Make sure you're copying this into your notes, because if you don't write it down, you're not going to remember it. There's a brain study. It says that if you just listen, I don't remember the percents, but maybe you remember 10%. And if you write it down, then maybe you learn 20%. And if you, so it's like see it, hear it, do it. There's all these. I got to find that for you guys so that you can see it. But basically, one thing I found more recently that I thought was pretty exciting was it's if you combine all of the things. So if you just hear it, if you just see it, there's these percentages. But if you see it and hear it, then it's more. So see it, hear it, write it, do it. That's what the practice problems will be for. Okay. Anyway, 4th root of 160. So My method, you don't have to memorize what the perfect fourth roots are. So what you're going to do is you're just going to make a tree. So make a tree. 160. Now, if you don't know how much goes into 160, totally fine. It's even. It ends in a 0, 2, 4, 6, 8. You could divide it by 2. But I'm looking at 160 and I'm saying 16 is like 2 times 8. So I'm thinking, well, I could do 2 times 80 or 20 times 8 or 40 times 4. Anything you do will work, whatever you happen to pick. So there's no particular reason for picking something. Maybe 16 times 10, because I see the 0 at the end, makes the 10. Whatever you pick is totally fine. So this is 8 times 2, 5 times 2, and then 8. Sometimes I'll do a little triple tree here, 2, 2, 2, 2, 5. I do always bring down my singles, because if not, then they're not all written at the bottom. Okay, and then you have a fourth root of this. So do you have any, now this is fourth root jail. So fourth root jail means that you got to have a group of 4 to escape from fourth root jail. So I do. Team 2 escapes and just becomes a single 2 on the outside. So single 2 on the outside, fourth root, re-multiply 5 times 2. Here you go. And if ever you feel like I go too fast in class, the nice thing about this is, remember, it's a YouTube video. You can pause it. You can also change your settings to make it more high def. If I've recorded it in 720p, I think, or 1080p. So you could definitely watch it more high definition if it's not clear. But the other thing you should do is you can watch it at slower or quicker. So I was listening to the other day and my voice was like really, really fast or really, really slow. Okay, so that's example 2. Let's do example 3. Example 3. We're going to put a letter in. Okay, so this one's a little bit different. You did not see this one first semester. So let's do, it's the cube root of 54 x to the 17th. And let's stick in a y. I'm thinking we should stick in a, well, maybe not for the first one. Okay, we'll do example 4. We'll stick in a y. Okay, so cube root of 54x to the 17th. Well, what kind of jail is it? So is it square root jail? Or is it cube root jail? Is it fourth root jail? How many partners, how many things do you need to escape? So 3. So I need 3 things to escape. So what I have to do is I have to break up the 54 and break up the x to the 17. So the x to the 17, I could just break up right now. Uh-oh, there's 17 of them. Okay, so 6, 7, 8, 9, 10, 11, 12, 13, 14. Let me shrink this. Uh-oh, I lost count. So I said I was on 15, but let's see, that's 10, that's, oh yeah, I think I wrote off the screen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, that's annoying. So it might be nice to put them in a group. So really, groups of 3 are the best way to write them. So I'll show you that after. But there's 2 different ways, and I want to show you the, not the long way, but kind of the more understanding way first, and then I'll show you a short way that I've come up with that I've used. Okay, so 54 is 9 times 6. If you don't remember that from your times tables, you could divide by 2. 2 goes into 5 twice. You multiply those, subtract, bring down. 2 into 14 is 7. So you could also make 54 tree and do 2 times 27. And then continue. But I knew it was 9 times 6, so I'm already breaking it down. So this is 3 times 3. That's 2 times 3. Everybody's a times when you're doing the trees. Do you have anything that comes out of a cube root jail? Okay, so this is a cube root jail. So what we kind of have so far is we have the cube root of this and this. That's not really official notation here. But basically you have the cube root of all that stuff. So what we have to see is we have to see if anything comes out. So let's focus on the numbers first. I've got the 3's. Okay, so I've got 3 3's, so they escape. So the 3 comes out. I still have the cube root. I'm going to leave space for the x's. The 2 I haven't used, so it goes inside. If there were multiple numbers inside, multiple numbers outside, you multiply them. Okay, so for the x's. Okay, I'm going to pause because my family is kind of talking and I don't know if you guys can hear them. So hold on a second. Oh, that's good. It worked. The other day I was pausing and then it quit the video. So I have to like tie 3 math analysis videos back together because I have them in 3 separate spots. Okay. I'm glad that didn't happen here. Okay. So the 3 comes out, the 2 stays inside. You already heard that. Now for the x's, every group of 3 comes out. So that x comes out. This x comes out. This x comes out. This x comes out. This x comes out. And I have 2 x's left inside. Now, usually you're not going to have to write that because I usually what I do is I do my circling. I'm just circling in yellow. I circle all 5, and then I think all 5 come out. But when the 5 come out, make sure it's multiplication in your brain because it's not that you write 5x, it's that you write x to the 5th. The cube root of 2, and then x times x to the 1 times x to the 1 is x to the 2 is the answer. I left a little gap. I try to leave a little gap because otherwise sometimes my exponent looks like it's in the corner. So I just want to make sure, is there a number in the corner? And then I write it out. Okay. Another way I would do example 3. So I'm going to do example 3 again. Okay, but it's the same example. You should write it again. So this, we'll put alternate. I would call it a shortcut. So this would be a shortcut. For the 54, I would do the same thing. So the 54, I would still do 9 times 6 or 27 times 2, 3, 3, 2, 3. So that's the same. But this is the thing. And I wanted to show you the other way because some of my my Algebra 2 students got confused, but probably because they couldn't pause. You know, in class, sometimes you're distracted. So if you get distracted in your house, you can just hit pause or rewind on these videos, but you can't really rewind me in class. You know, sometimes you can ask, but there's just, you know, it's more embarrassing sometimes to ask questions. Okay, so, and you can ask questions, I believe, on the YouTube videos in the comments, and then I could still answer them. I'll have to see if that works. Or you can send me a text. If you're one of my students, you have my cell phone number. So you can send me a text and ask me questions on any of them. Just tell me example number 3, video number 5, whatever, and then I'll help you. Okay, so cube root. So this 3 in the corner means that I want groups of 3. So if I want groups of 3, why don't I originally write them in groups of 3? So group of 3, group of 3, group of 3, group of 3, group of 3. I have to remember how many x's do I need, though. I need, what, 17 x's? Okay, so that's 5 times 3 is 15, so I have 15 x's so far. And then I still have 2 x's, but I don't make another group of 3. So this x comes out, this x comes out, this x comes out, this x comes out, this x comes out. So that's x to the 5th that came out. Still cube root. The 2 x's in here is x to the 2nd. And then I do need to do my numbers. So what were my numbers? Cube root jail. So I need a group of 3. They escape. I always draw the arrow so that in the future, like what if you see this in Algebra 2 or in geometry or calculus later and all of a sudden you think, what am I going to do? What do I do? Maybe, which ones do I bring out? Which ones do I stay in? So maybe you'll remember the circle arrow. That's the one that goes out. And then what's left over stays inside. So that's a 2. So, of course, you get the same answer, hopefully, if we do it the right way. Okay. We have that one. We have this one. Okay, how many minutes are we at? We're at 18 minutes. Okay, I think you should practice questions like this before you do the rest of the problems. But I'm not sure I really want 6 videos. So what I'm thinking, I think I want 6 videos. So I think I'm going to make 6 videos. And what I'm going to show you next, it's called cube roots in the denominator. There's 3 of them. There's 3 examples, but they're pretty complicated. Definitely something that even Algebra 2 students have difficulty with, but it would be nice if you saw it ahead of time. And then you won't be scared by my video seeming to be like 40 minutes. You're like, I'm not watching that video. Okay, and it did say we had 6. So this will be 5, and then 6 is coming.